Hey everyone, and welcome. Today we're going to talk about how a material you see literally every single day, plastic, is about to have a massive moment. We're talking about polymers, and they are getting ready to completely reshape how we generate, store, and even think about energy.
I mean, it sounds like something straight out of a sci-fi movie, right? But believe it or not, these are the exact kinds of questions that scientists are not just asking, but actually answering right now. The whole idea is to get away from the clunky, separate power sources we're all used to, and instead weave energy directly into the world around us. But to get there, we've got some big hurdles to clear first.
Just think about the battery in your phone for a second. It's this solid, kind of heavy brick, right? Or the power grid itself. It's centralized and super rigid. And a lot of our traditional batteries use these liquidy electrolytes that can be, well, flammable. You can see how all these things really limit what we can design and build. If we want technology that's truly integrated, wearable, and flexible, we're going to need a whole new kind of material.
And that right there brings us to the hero of our story today, polymers. These materials are the absolute key to unlocking that flexible future we're talking about, solving all those problems of weight, stiffness, and safety. So to really get it, we first need to ask, what in the world is a polymer anyway?
You know, it's actually a pretty simple idea when you break it down. Just picture a super long chain, maybe made of thousands of identical paper clips linked together. A polymer is basically the molecular version of that, a gigantic molecule built from all these smaller repeating parts. It's this long chain structure that gives plastics, rubbers, and even gels their unique feel. And it's that very structure that we can now engineer to do some incredible things.
So these are the superpowers that make polymers the perfect candidate for this energy revolution. I mean, they're naturally flexible and super lightweight, which is perfect for wearable tech. They're also chemically stable, which makes them way safer. But here's the real magic bullet. They are tunable. This means scientists can literally design them on a molecular level, like changing the chain length or swapping out little chemical bits to give them the exact properties they need. Whether that's conducting electricity or storing ions, they can build it from the ground up.
So in the big world of energy tech, these engineered polymers basically have two main jobs. They can either help create electricity from another source, or they can help store that electricity for you to use later. Let's dig into what that actually means. Okay, so on one side, you've got energy conversion. A perfect example is a solar panel, right? It converts sunlight into electricity. Then, on the other side, you have energy storage. That's your battery, saving up that power so you can use it whenever. And polymers are making huge breakthroughs in both of these camps. Let's see how.
For conversion, think about this. Conductive polymers are letting us create organic solar cells that are so light and flexible you could literally print them on almost any surface. And in fuel cells, we've got these special polymer membranes that act like a super selective bouncer at a club. They let the right energy-carrying particles through to make electricity, but they block everything else. It's a total game changer for efficiency.
And now for storage. And this is where it gets really exciting for the gadgets we use every day. Scientists are developing what are called solid polymer electrolytes. These basically replace that flammable liquid inside traditional lithium-ion batteries. That makes them way safer, and it lets us create batteries that can actually bend and flex. And for supercapacitors, the ones that charge up crazy fast, conductive polymers are boosting their storage power to brand new levels.
Okay, so this all sounds amazing in theory, right? But what are the actual results? Is this stuff really working? Well, let me tell you, the data coming out of research labs right now is, wow, it's absolutely astounding. Let's take a look at a few quick snapshots from the front lines. Get a load of this number. By mixing in some reinforcing particles into a natural rubber, scientists cranked up its fracture toughness by 484%. So what does that actually mean for you and me? It means our future flexible devices won't just bend, they'll be tough enough to survive being dropped, sat on, and generally abused, making them way more durable. Okay, what about longevity? Well, researchers made a rechargeable battery using a polymer hydrogel, which is basically just a squishy water-based gel, as the electrolyte. It survived 800 full charge and discharge cycles with almost no drop in how much power it could hold. That's the kind of reliability we need for devices that we use constantly. And finally, let's talk resilience. A team created a flexible supercapacitor that they could physically stretch and pull on. And even after all that stress, it recovered over 96% of its original power storing ability. That's proof that these things can handle the real-world wear and tear of being woven into our clothes or built into our gear. All right, so we've got materials that are tougher, last longer, and are way more resilient. So where is all this headed? What does a future powered by polymers actually look like?
You can really think about how we use energy in three big stages. We started with these huge, centralized power grids. Then we invented portable power, batteries, that let us take our devices on the go. Well, the next logical step, the one polymers are making possible, is integrated power, where the device and its power source are one and the same.
And that just blows the doors wide open for what's possible. We're talking about electronics literally stitched into the fabric of your shirt, power sources that are biodegradable or easy to recycle, which would solve a huge environmental problem. And, get this, multifunctional materials. Imagine an electric car where the body panels themselves are the battery, getting rid of that single, massive, heavy battery pack.
You know, you don't have to take my word for it. The scientists who are leading this charge, Kumar and Dalam, they put it perfectly. This isn't just a small improvement. They say these new polymer systems are key enablers. In other words, they are the foundational tech that will unlock the entire next generation of energy.
This is a really fundamental shift we're looking at. We're going from a world where we carry power with us to a world where power is just an inseparable part of the things all around us. And that leaves us with one final fascinating question to chew on. When energy is no longer a brick in your pocket, but a thread in your jacket, what new possibilities will we even be able to dream up?